Hey guys, Danny here at PARTAY. So I started on Vega again this morning. It started raining, sun came out, it dried up. I thought we were going to get another chance, and as you can see, we've got another storm that's moving in now over us. I'm expecting the bottom to drop out at about any time. It may even while I'm doing this video. So I will hold good to my promise of putting Vega together. It's just a matter of I need a window of opportunity. The guys are busy in the clean room today, so I'm not going to make a trip over there. I may have to later this evening if it doesn't look like it's going to clear up, but we'll see. I'll play that by ear. But first, I started last night putting all the material together that I've gathered, graphics and things of that nature, for the game series. And what became very prevalent to me as I was looking through it was that first we need to talk about light. So instead of this being a three-part series, I'm going to do part one of just the basics of light that you need to understand and how they apply to projection. And then we'll talk about the fundamentals of gain, and then we'll go into part 2 and 3, which are your long throw, standard short throw, and ultra short throw components, implications, right? All right, so with light is essentially, in a nutshell, guys, I mean, I don't want to get too technical in this because I don't want to bore people, and I'm going to try to focus more on, how it pertains to projection. But let's just say light in its creation, right? Light is essentially just an output from an excited electron, okay? So it creates what's called a photon. Think of it as laying an egg at speeds we would never be able to perceive. But that light starts traveling. It travels very fast, somewhere in the ballpark of about 670 million miles an hour. And it's relatively unobstructed by anything except for physical objects, okay? Example A, everything that you're seeing out here, you're seeing as a result of light reflecting off of these things. Okay, and light does one of three things. Okay, there's basically three behaviors that happen after light's created. One, it travels, but that's not really one of the three. But in its travels, it's either going to be absorbed by a physical object it hits, it's going to be transmitted by a physical object it hits, or it is going to be reflected by a physical object that it hits. Okay, or it could be a combination. In fact, in most cases, it's going to be a combination of the three, and according to the type of object that it hits, it would be predominantly one or the other, or, two or the other, or whatever it may be. So as an example, like I said, the things that you're seeing out here, reflective, if you've got the white columns here, most of the light's being reflected off the white columns. There'd be some absorption, not really much in the way of transmittance. Whereas a leaf, if you grabbed a leaf, you notice you hold it up to the sky, a lot of times you can see light kind of come through it. Not directly through it like it has a hole, but you can see it sort of, illuminated through it. So like a lampshade, it transmits light. So some light is absorbed, some may even be reflected, on the inside, but there's an amount that would be transmitted through, and that's sort of how you create diffusion, is through transmittance. Okay, so those are the behaviors of light. So when you think about light leaving your projector and traveling through a room that you're sitting in, okay, the key thing that you need to understand is that nothing really happens to that light once it leaves your projector until it hits the screen. The light that's in the room does not interfere with your projector light. Not at all. Not in between the projector and the screen. It does not. Where that fight happens, as we've stated many times in the past, is at the screen surface. And here's why. You would think, and I'll use my projector as an example. My projector is 3,000 lumens, ANSI peak rated, right? It's the Optima HD143X. In the modes that I use it in, so I typically keep it in, it's pretty much always in eco mode. I think I put it in bright mode a couple of times outside here, but it's in eco mode, okay? It's in either cinema or vivid mode according to the room that I'm in, and it's also in 2.4 gamma. Okay, I don't have dynamic contrast on. I don't have the brightness. Brightness is usually down, -2, and I usually have my contrast bumped about 2, sometimes as much as 4 according to what content I'm watching. Okay, but no more than 4, and that's on a scale of 0 to 100. I'll have it, you know, set at about 4 above median. Okay, not -4, but 4. So pretty standard settings, except for the gamma. Most people use about a 2.2 gamma rather than a 2.4. I like a little more contrast and pop, so I'll use the darker gamma. But in those settings, from 12 feet away in a dark room, controlled room, it's only pushing 520 lux on the surface. 520 lux, guys, from a 3000 lumen rated projector, right? And that's pretty typical. I think it surprises a lot of people that it's so low. That's all the amount of lux that would be hitting the screen. So it starts to beg the question, at what point does ambient light, you know, lux from ambient light, start to overpower the lux from your projector? Okay, so by our best estimates, the real implications start at about 35% of your total lux from the projector. And if once you get up to essentially 50% of the lux of your projector, it would start to degrade the image, okay? And this is going to be where gain comes in. So this is sort of the segue into gain. So that'll be our next one. But if you think about it, 520 lux, if I've got 400 lux of just ambient light coming in, that means essentially the bulk of all of the light that I'm pushing out to that surface. Okay, let's just say this was our screen surface. So if I've got 520 hitting it and 400 are coming in, you know, white Kelvin light from window, it's going to overpower your imagery. Your colors are going to be diluted. That's where the fight happens, is on the surface. And I want to preface that, because as we get into gain, some of the things that work for PARTAY screens and what makes them optical screens are that we take the fight away from the surface. Okay, but at that surface, that's the reason you're going to have a problem. It's not because the light in the room has diminished the light from your projector or causes your lumens to fall out of the sky. It's nothing stupid like that, guys. It all happens at your screen surface. And then the gain is really going to be a big part. So you have illuminance, which is, you know, your IL luminance. So illuminance is going to be the amount of light that you're pushing onto the screen. Luminance, without the IL, is going to be the amount of light that is returned from your screen. So there's going to be concept of luminance and illuminance that we're going to talk about in the next series, part 2, where we talk about the foundational components of gain. And we're going to get into something that's actually pretty cool when we start talking about beam angles. You've heard me talk about beam angles in the past, and how excuse me, floodlights and things like that have a very different beam angle and less intensity than people tend to think that they do. So we're going to talk more about beam angles of light and how that actually can improve or make worse your imagery. So I give you as an example, most people think if you move your projector from 12 feet to 15 feet back, it won't be as bright. That is true in many cases, not all cases, but in many cases that may be true, but it's not because of distance. So it's all because of beam angle, and we'll talk about that in our next upcoming part. All right, so hopefully this has been somewhat enlightening for you guys. This is just a predecessor to our actual series, so we'll get into more about gain. We'll talk about beam angles. We'll talk about how the light interference at the screen surface really impedes your imagery, and that's what everybody's essentially looking for the coup de grace in a screen for. So you guys have a great day, and we'll talk to you soon. Bye.